The properties that we introduce for logarithms work in both directions, meaning that if we can expand an expression, we can also take an expanded expression and condense it down to a single logarithm. To do that, we'll start off by looking at the first two terms in example 4. We have the natural log of 12 plus the natural log of y. Since we're adding those two expressions together, we can combine them by rewriting this as the natural log of 12 times y plus the natural log of r, which we haven't done anything with yet. But now we can look at the expression that we have and see that we have the natural log of one expression plus the natural log of another expression. We're adding those together, so to condense those, it will turn into multiplication again. This will become the natural log of 12y times r. And whether or not we put those multiplication dots in there at any point really doesn't matter, since we assume that letters written next to numbers or letters written next to each other are multiplied together. Our final answer could be written as just the natural log of 12yr. In example 5, we're subtracting two logarithms, so we can combine these as the log base r of 12 over 5. And then if it did turn out that our value is reduced, we would want to reduce that fraction. In example 3, we want to condense this expression, making sure that we have a leading coefficient of 1. Right now we have a leading coefficient of 1/3, so what we want to do is get rid of that coefficient out front. Since this is a logarithm, we can rewrite this as the log base y of 125 to the 1/3 power. What we've done is use that power rule in reverse. We've brought that coefficient out front up as an exponent, and now we can simplify 125 to the 1/3 power, which will just be 5. So keep in mind that's just the same thing as the cube root of 125. In example 7, we again want to condense this expression, making sure we have a leading coefficient of 1. We have no coefficients in front of that log expression, so there's nothing to worry about there. All we need to do is merge these two expressions together. Since they're being added, we'll do that by multiplying those two expressions together inside a single logarithm to get the log base y of 3x squared times 4x to the 9th. Then we can multiply those factors together to get 12x to the 11th, which we get by multiplying x squared times x to the 9th, and we merge those by adding those exponents together. In example 8, we again want to condense this into a single logarithm with a leading coefficient of 1. We have no coefficients out front, so there's nothing to worry about there. Since we're subtracting, we'll combine those expressions into a single logarithm using division. This will become the log base c of 4x cubed over 5x squared, which will reduce to the log base c of 4x over 5. Because we'll combine those x terms, or those x factors, by subtracting those exponents to get x to the first power. In example 9, again, we want to condense this logarithm. We want to make sure we have a leading coefficient of 1, and we want to make sure that's the step that we take care of first in this example. Before we merge logarithms, we need to get rid of these coefficients in front of those logs. So our first step will be to leave the first term unchanged. But for the second and third log, we'll bring those coefficients up as an exponent. So this will become the log base m of a to the fourth power minus the log base m of w to the ninth power. Now that we've taken care of those coefficients, we can look at combining the first two log statements using multiplication. And then our last step will be to combine the remaining two log statements using division. So we'll end up with the log base m of n times a to the fourth divided by w to the ninth power.